Good morning, sir, and good morning, everyone. My name is Vivek, and I am here to present my final project of the course Machine Learning. So, the title of my project is Prediction and Analysis of Lung Infections Using Deep Learning, a comparative study of InceptionResNet V2 and VGG19 models. So I'm going to just give you a brief introduction to my project. So the project is basically classification of various lung infections, and I took a data set from NIH website. It is a open data set. Anyone can download that. So the data set is very huge. It is about 45 GB in size, and it has more than 100,000 images from 30,000 patients from all over the world. So our aim is to evaluate the performance of both models in identifying various lung infections, including pneumonia and many others. The VGG19 model, known for its deep architecture and simplicity, is compared against the InceptionResNet V2 model, which combines the Inception and ResNet architectures to achieve state-of-the-art performance on various computer vision tasks. Both models are fine-tuned using transfer learning techniques on the given dataset. Through rigorous experimentation and analysis, we assess the classification accuracy, computational efficiency, and generalization capabilities of both VGG19 and InceptionResNet V2 architectures. And coming to the title justification, the proposed model predicts and analyzes the lung infections that may occur to the patients. A comparative analysis of the performance of the models is made to identify the model with better accuracy. And these are our objectives: to compare two models for classification of lung infections and identify which model suits the best. So the scope of the project is limited to healthcare professionals who want to identify the lung infections from X-ray images, health organizations that takes necessary actions on the basis of analysis, and also patients who have access to the chest X-ray scans. So these are some basic concepts. This is the basic concept of InceptionResNet V2 architecture, and it is just a brief introduction to the VGG19. And so these are all the modules that we are going to do in this project. So the first module obviously includes data collection and pre-processing, and the second module includes data cleaning, and the third module is data visualization, just to represent different classes. As I said before, there are totally 15 different classes of diseases that we have classified. So basically in those in those 100,000 images, all of them are not infected. Only few patients are infected and few patients are not infected, so we are going to classify them as well. And then followed by model building, training, and evaluation, and lastly the comparative analysis of InceptionResNet V2 architecture and VGG19 architecture. So this is our proposed architecture for this project. The first step includes data collection and pre-processing, as I said before, and which process the lung data set, and it goes on to two different models. Then we identify the accuracy and we select the model with the best accuracy, and we apply that for our future data sets. So coming to the data collection, as I said, this is NIH. The data is collected from NIH. It is an open source data set. Anyone can download that. Here is the link to the data set. And these are the 15 classes. 14 are diseases and one for no findings. That means that image does not have any disease, and the patient is not at all infected. And all the 14 other diseases are mentioned here. These are the 14 diseases that we are going to classify in this project. And this is the data set. These are some sample chest X-ray images, and here you can see the total count of the images, and it says, I can also show you a live demo. Yeah, here is our data set, and yeah, here you can see 45 GB of data set. Yeah, so the first process, data pre-processing, which includes cleaning and visualization. So as I already said, there are 15 classes, and these are different categories of lung infections that we are going to classify. So initially we load the chest X-ray dataset, process the metadata, and prepare the data for further analysis or machine learning task. We generate a bar chart to visualize the distribution of top 15 most frequent finding labels in the chest X-ray dataset. As I said, there are many patients who are not infected, so for them it is no finding, the first one here, and followed by the other diseases which are identified in the X-ray images. And later on, we create a balanced subset of chest X-ray dataset by sampling rows with probabilities proportional to the number of finding labels associated with each image. So the resulting subset is then visualized to show the distribution of top 15 most frequent finding labels. And yeah, in this particular thing, we just remove the no finding, the all the images which doesn't include any infected person's lung chest X-ray, and then we are generating a bar chart to visualize the adjusted frequency of diseases in a patient groups based on all the XRDF data frame. The mean frequency of each disease is calculated and expressed as a percentage, and the resulting data is visualized in a bar chart to facilitate interpretation and analysis. So this is a bar chart which is adjusted frequency of diseases in patient group. And finally, then we prepare the image data generators for training, validation, and testing the model. The image data generator object is used to generate augmented image data for training and validation. The flow from data frame function is used to create a custom generators that yield batches of augmented image data and corresponding labels from data frames containing image data. The test image data is visualized in a 4x4 grid of subplots. So as you can see, these are different chest X-ray scans that have been infected. So this particular thing has consolidation, and this has fibrosis, and this has mass, this has infiltration, this has effusion. Yes, and so this is the process of InceptionResNet V2, what we have done. And so the first step obviously includes importing several libraries such as NumPy, Pandas, Matplotlib, and Keras, and loading the data. So we also have a CSV file which is also available in the NIH website itself. This is a folder named data entry. Uh, it just contains a metadata about chest X-ray images, and then data pre-processing. So we pre-process the data by cleaning the labels, creating binary labels for disease, and filtering out labels with fewer than a certain number of cases. It also samples 40,000 images based on calculate sample weights. Data visualization. So we already saw here, these are the data visualization, data augmentation, and we perform data augmentation using image data generator from Keras. And model building, we build a CNN model using transfer learning with the InceptionResNet V2 architecture pre-trained on ImageNet. The model is compiled with Adam optimizer and binary cross entropy loss. Model training, the model is trained using fit generator method on the training data with 5 epochs, and followed by model evaluation and model performance visualization. In model performance visualization, we will draw the ROC curves for each diseases. And finally, image prediction visualization, it generates and saves images with models prediction and actual diagnosis for the sickest patients in the test dataset. So yeah, as I mentioned earlier, this is the ROC curves. Uh, we define and train a deep learning model for multi-disease classification using the InceptionResNet V2 architecture. The model is trained using a custom generator that yields batches of augmented image data and corresponding labels. The model is evaluated using ROC curves and AUC scores for each disease label. The image is a plot of receiver operating characteristics. As I said, the ROC curves for each disease, and this is output we got. In this particular thing, the DX means true positive rate and PDX means predicted positive rate. Lastly, we generate a 4x2 grid of subplots that displays the images of 8 sickest patients in the test datasets, along with the top 3 true and predicted disease labels. As I said, the DX and the PDX. Yeah. So this is the summary of InceptionResNet V2 model architecture. This particular table over here, this is output we get when we run the code. And coming to our second model, which is VGG19. So the steps also includes very similar things. The first one being data loading and pre-processing. It is similar to the InceptionResNet V2 architecture. We use the same method, same functions, everything same, and followed by data resampling. It also is the same. Uh, these are the things we perform in the VGG19 architecture as well. Then we process later the data with VGG19 architecture. In this model building, we start using the VGG19 thing. So the code imports the VGG19 pre-trained model without the top layers and adds additional layers for classification. Global average, pooling, dropout, and dense layers are added for classification. The model is compiled with Adam optimizer and binary cross entropy loss to get the accuracy and everything. Model training, the model is trained using the fit generator. As usual, we also use the same method for uh, InceptionResNet v2 as well. So the output for both InceptionResNet v2 and VGG19 includes the training history, loss, binary accuracy, and mean absolute error. We use the Keras image data generator class to perform data augmentation and preprocessing on a dataset of grayscale images. The dataset is stored in a pandas data frame, and the code defines a function flow from data frame that takes the data frame and generates augmented images using the image data generator. So these are the images from our test datasets. As you can see, some has mass and nodule, some has a fusion, infiltration, and some has only infiltration. And this is the summary of our VGG19 model architecture. So the final module, which is analysis and accuracy, these are the result we got for VGG19 and InceptionResNet. For VGG19 we used 4 epochs, and for the InceptionResNet v2 we used 5 epochs. Validation loss and binary accuracy and mean absolute error we got uh, yeah, for validation loss, VGG model has more validation loss than the InceptionResNet v2 model, and the clear explanation is given in this slide. So the VGG model achieved a validation loss of 1.9 after 4 epochs. In contrast, the InceptionResNet model has achieved a notable lower validation loss of 1.4. This indicates that the InceptionResNet model coverage to a lower loss value, suggesting better performance in minimizing prediction errors compared to the VGG model. And the same includes for the validation binary accuracy and validation mean absolute error as well. So coming to the validation binary accuracy, the InceptionResNet model made more accurate predictions on the presence or absence of lung infections compared to the VGG model. And coming to the validation mean absolute error, this suggests that InceptionResNet model provided more precise predictions of the severity of lung infections compared to the VGG model. So in conclusion, in addition to the quantitative metrics provided, it's imperative to consider the architectural differences between the VGG and InceptionResNet models. The InceptionResNet model incorporates intricate features such as residual connections and inception modules, allowing for more effective feature extraction and representation learning. So, in conclusion, while both the VGG and InceptionResNet models exhibit proficiency in classifying lung infections from chest X-ray images, the InceptionResNet model emerges as the superior choice based on its superior validation performance. Future research could delve deeper into fine-tuning hyperparameters and exploring alternative architectures to further optimize model performance for this critical healthcare application. And these are some of the references from some papers that we have taken for reference. Thank you, and let me show you my code. So this is a program for InceptionResNet architecture. Initially we have imported all the required libraries, and then we started processing our data. As you can see, there are a total of 1,12,000 images. Then we have generated this plot, which is basically data visualization. Then we got this plot which has which we remove this particular thing. This is the adjusted frequency of diseases in patient group, and then we start preparing the training data, and followed by creating the data generators. And now we can see these images, the lung classification, the few images as infiltration, and this one has edema, effusion, and infiltration. Then we start the InceptionResNet architecture. So here is the summary of the InceptionResNet v2 architecture, and here you can see the accuracy, like the binary accuracy over here, the loss over here, the mean absolute error over here, the validation binary accuracy, and validation mean absolute error over here. And later on the predicted values and the true values also here the dx and pdx, and this is the ROC curve that we have plotted for individual diseases. And these are the particular images. So these are the images of 8 sickest people in the entire data set. You can also see the dx and pdx values for these as well. So this is the InceptionResNet v2 architecture code. I will attach both the InceptionResNet code and VGG codes, the IPNB files in the submission zip file also. And this is a VGG19. This includes the similar steps, just inputting the data and processing the data. The first steps are same, then the preparing the training data is also same, the data generators is also same. Here we can see these things, and later we start implementing the VGG19 architecture. Here is the summary of the VGG19 architecture, and yeah, here you can see the loss, the binary accuracy, the mean absolute error, the validation loss, the validation binary accuracy, validation mean absolute error. So by comparing this, we conclude that the InceptionResNet v2 architecture is much more efficient for lung classification in both healthcare industry, as well as if the patients want to just scan the images themselves. And here is the term paper that I have written. It clearly, more than the PPT and more than the code, this particular paper has much more information about the exact steps that I have followed and everything. It includes every data. These are all the references that I have used, the summary of the references. It clearly has much more information. And thank you everyone, and thank you sir for supporting us this entire semester and guiding us through different concepts that we have never learned. That is my project. Thank you.